You are welcome back. You are welcome to study session 8, and the topic we are going to consider is oxidation and reduction. At the end of this study session, you are expected to have been able to know the following. 1. You should be able to define oxidation and reduction as explained in the study. Then the second thing that you are expected to have learned after this study session, you are expected to have known how to predict oxidation states of the component of the compound. And lastly, you are expected to know how to balance a redox reaction. Oxidation could be defined in various ways. 1. You could define it in terms of removal of oxygen or removal of hydrogen. You could define it as a process of electron transfer. You could equally define it as a gain or loss of electron, and at the same time you could define it as an increase or decrease of oxidation number. For the purpose of this study, I will want us to concentrate on one of the definitions, which is an increase or decrease in oxidation number, because that is paramount to identifying the substance that is oxidized and the one that is reduced. Oxidation is a process of electron loss, in which an atom loses an electron. When there is a loss of electron, such a process is called oxidation. And when there is a gain of electron, that is called reduction. Another thing that is important for us to study, like I said earlier, that I want us to concentrate on increase and decrease in oxidation number. When you have an increase in oxidation number, you call it oxidation. And when you have a decrease in oxidation number, you call it reduction. I want to show two examples to illustrate what I'm trying to explain. Copper 2 plus 2 electrons giving us copper. The oxidation number of copper here is plus 2, as shown from the chart. The oxidation number of copper here is 0. Movement from plus 2 to 0, this is called reduction. The other way around, if you have zinc, oxidation number for zinc is 0 here. In the product side, oxidation number is plus 2. From 0 to plus 2, that is an increase. When there is an increase, you call it oxidation. Summarily, when there is a reduction in the oxidation number, it is called a reduction process. When there is an increase in oxidation number, it is called an oxidation process. The importance of redox reaction. It is a reaction that we come across on day-to-day affair. The bleaching of substances away. Maybe if our cloth is dirty and you want to remove the stain, you employ a bleaching agent. What occurs when you are bleaching is oxidation and reduction. When you put a nail outside, after several times you discover that there will be a rust on that nail. What happens to that nail is basically an oxidation and reduction reaction. Another good example is when you look at the old roofing sheet. You discover that when it was first done, it will be shiny. After some time, it will appear brown. What has actually happened there is basically oxidation and reduction. So it's a concept that we come across on a daily basis. And at the same time, metals are not available freely. They are available in the combined state called ores. For us to be able to get the metal, it has to be purified. And in attempt to purify, you employ the principle of oxidation and reduction. So it's an affair that is a concept that we come across on day-to-day activity, and it's around us. So let's take a look at how to balance a redox reaction. There are various steps that we need to employ in balancing redox reaction. Basically, there are 6 of them. 1, you identify the species that is performing the oxidation and the one that is performing the reduction. You write it in 2 ways. The half for oxidation, the other half for reduction. Then you balance each of the half reaction by adding oxygen and hydrogen, as the case may be. Then the third step, you balance the half reaction electrically by adding the same number of atoms of electrons to the side with the higher oxidation state. Then the fourth step, you obtain the net redox reaction by confirming the two half reactions after the number of electrons must have been made equal in the two half reaction. And the next one, you simplify the net equation by bringing the species together. And lastly, that's step 6, you balance it both atomically and electrically. These are the various rules for assigning oxidation states, which you have to learn by heart as you work with them. Oxidation state of an atom in an element is 0. An example is sodium. Oxidation state of sodium, Na, in the solid state is 0. And likewise for mercury, in the liquid state, Hg is 0. The second one, oxidation state of a monoatomic ion, is the same as its charge. If you have sodium carrying a positive charge, the oxidation number of that sodium is +1. Chlorine carrying a negative charge, the oxidation number of that particular compound is -1. Fluorine has oxidation number of -1 in compounds that it combines with. Oxygen is usually -2 in its compound, the exception is in peroxide. And the last one, hydrogen is +1 in its covalent compounds. So these are things you will learn as you work with them. A good example that I want you to understand in calculating oxidation state, we are going to look at two of them. The first one, you consider carbon dioxide. And I'll underline carbon because I want to find the oxidation number of carbon. The one I want to find are indicated by F because it is unknown. In the previous table, I said oxidation number of oxygen is -2. -2 times 2 atoms of oxygen. -2 times 2. Then you equate it to 0 based on rule number 1. This becomes x plus -4 equals 0. X minus 4 equals 0, and x becomes +4. The oxidation number of a carbon in carbon dioxide is +4, and that's the reason why you call it carbon 4 oxide. Carbon 4 oxide. Another example that is worthy of note is the one that carries a charge, NO3-. Assuming we have to calculate the oxidation number of nitrogen. Nitrogen, like I said, is X because it's unknown. Oxygen, the combining power of oxygen in compounds except in peroxide is -2, like we did earlier. -2 times 3 equals -1. X minus 6 equals -1. X equals to -1 plus 6. X now becomes +5. So here, the oxidation number of nitrogen is +5. The oxidation number is very important because it tells us the combining power of elements in compounds. So let's go back to the next on our study. Disproportionate reaction. Reducing agent is a substance that makes it possible for the other substance to be reduced, while oxidizing agent is a substance that makes it possible for a substance to be oxidized, but in itself it will be reduced. And I will equally want us to know that a compound that's an oxidizing agent in the reaction can equally be reducing agent in another reaction. It means they could behave in different ways depending on the reaction in which they find themselves. A good example is hydrogen peroxide. It could behave as both oxidizing agent and a reducing agent depending on the substance it is reacting with. And we are going to look at this example briefly. The reactant side here we have H2O2, 2Fe2+, and in the product side we have 2H2O and 2Fe3+. Ion is moving from oxidation state of +2 to +3. Like I said earlier, when there is an increase, that is oxidation. And the substance that is undergoing oxidation, substance oxidized, is called a reducing agent. If ion that is oxidized is called a reducing agent, the peroxide that is reacting with it is now called an oxidizing agent. So H2O2 in the first example is behaving as an oxidizing agent. In the second example, H2O2, we have MnO4-, and going by the product side, we have Mn2+. The manganese is moving from +7 to 2, that is plus 2 as a reduction. Substance that is reduced is called oxidizing agent. So it's called oxidizing agent here. And the peroxide here is now called a reducing agent. So it could behave in different ways. It could be an oxidizing agent, and at the same time, it could be a reducing agent. Thank you for listening. I will see you in the next class.